Hey everybody, this is Larry. This is August 9th, 2025. I'm trying to do a bonus problem that we haven't done before. We've done a lot of problems over the years. What are all these other things? I guess only four. Huh. Not that many on the other ones. They put in such an emphasis, but not so many. Maybe some JavaScript ones. But in any case, yeah, let's stick with algorithms. And today we'll do maybe a medium one. Let's try to do a medium one that I haven't done yet. I don't like the hard ones, not because, well, maybe it is because it takes too much time, but also because some of them are just like research problems. I kind of took a peek at the ones I've left. They're like, oh, do you know this algorithm? And I'm like, well, I guess I don't, so I don't know how to solve this one. And then that's it. Right, so that's why I don't know, I find it less interesting. Maybe I'll get to it eventually. We still have a good amount of, well, 165 medium problems. So once we get through that, maybe we'll look at the hard ones. Anyway, today's bonus problem, we have 1090. Not a premium problem as far as I can tell, and I haven't done it yet, so it's new to me. So come hang out and solve this problem together. All right, we're given n items value and label as two integer arrays. Okay, values and labels. You are also given two integers numbers wanted and use limit equals to 1. The task is to find a subset of items with the maximum sum of the values such that the number of items is at most numbers wanted. Okay, the number of items with the same labels at most use limit. Okay, the subset chosen is the first because they have one of each label. Okay. I mean, honestly, the first intuition that I have is that this is like a hard problem, complexity-wise, meaning that I want to say it is close to NP. I don't know that that's true, but it does have that sort of feeling, unless I'm misunderstanding it. And so that's why the first thing I do is look at constraints to make sure that there's no like 2 to the n type algorithm expected. Of course, yeah, huh. Of course, the even given that, let's say this is some subset sum, yeah, max subset sum type problem. Oh, I forgot to get milk. I just forgot. Yeah, okay, anyway, unrelated. Okay. Some subset sum problem, which is going to have a pseudo polynomial solution with dynamic programming or something like that. So I still look at the constraint, and maybe you can kind of think of it that way. I'm not quite sure that that's the thing, right? I mean, labels. Labels by, or this means is that effectively, there could be as many labels as you want. Yeah. So then now, then we have to try to figure it out, right? Well, yeah. I mean, I think what I did say stuff, but maybe I'm just wrong, right? In the sense that, okay, well, what's the next thing, right? Well, use limits is equal to 1 is actually maybe a good hint in a way. And what I mean by that is that, okay, well, if you could use 1 from each label, what can you do? And I think the thing that actually fooled me about, and I did say this already, right? Like it intuitively maybe feels like NP or whatever, and you know I just mentioned it, but honestly maybe I was a little bit of a haste because it just had like some sort of subset and maximal sum. But the reason is because then now I just have to think about it a little bit, and I go, well, yeah, if the use limit is equal to 1, well, what does that mean? Well, the thing is that the items, the values don't interact with each other, right? And what I mean by that is that if you pick a 5, like it doesn't matter, like I don't know how to describe it quite precisely for now. I don't know. I mean, I this is recorded live, so some days, you know, it's a little bit off. But what I mean is that, okay, like if I take this 5, does it stop me from taking any other number? No, right? In contrast, what I mean by that is that I mean, there is something about most wanted and use limit, but not in a directly relating to the values, right? So the value part is the part that makes it, or that being not part of the optimization or the sub constraint makes it so that you are allowed to use greedy. And what I mean by that is that, like, if you look at what's it called, the one where you like bin packing type things, and that kind of subsets some. The thing is that if you take a large object and it takes away space in a constraints in a way that maybe like if you're trying to fit in a container of like size 10, you can't just like you could take the 7, but then you could also maybe take 2 5s, etc., right, on this one, right? But for this particular problem, you could just apply a very basic exchange argument of that, well, if you use a 5, nothing stops you from using the 4, right, in the constraints. So in that sense, I did misspeak, or I was just too early in thinking about these constraints or the hard problems and looking at the constraints. This is actually a very straightforward sorting problem, right? Because and use limit equals 1 gives you that hint, as I kind of alluded to earlier, meaning that, okay, you have use limit equal 1. What does that mean? Well, that means that for everything with the same label, we only need the top 1, right? And that's it, because nothing would make sense for you to get even the second best if use limit is equal to 1, right, of the same label. And you could kind of use that same logic with number 1 as well, with all the labels being the same, and then it's just about figuring how to merge them together. So all in all, this is a greedy problem and a sorting problem, and maybe someone of my my video, like I probably maybe should have jumped to that a little bit earlier, but maybe I just saw subset sum and kind of think of it that way. And the reason why I talk about all this, even though they were not related directly to the solution, is that I just, these are the videos that I want to give you my thought process about, right? And sometimes my thought process, even me being quote unquote good, or I don't know, maybe not, however you want to phrase it, or is good enough, I still kind of, like, I don't always jump right to the solution, right? Like, I'm like, oh, wait, but that doesn't make sense because, well, honestly, you can't get that to work because n is too big. You can't even use pseudo polynomial because likely it's going to be n times value sub I, if there's like a DP type thing, even without really digging into the problem, that's going to be too big, so that's not feasible. So I have to I'm basically forced to come up with a better one, and then that's when I'm like, oh yeah, duh. So sorting / greedy, right? Anyway, so then now we can we can sort all these things, right? So we have values, labels, and we want to sort them by values. Label I don't think matters too much, kind of, right? And then now we have for VL we want to sort this reverse is equal to true because we want the biggest values first, right? And it will sort by values. And then we want to just put in like a counter for a frequency table, so that we can, for each label, maybe I should, for each label, so that we don't go over the use limit. And that should be mostly all we need, right? So basically we go if f of L is less than use limit, then we can use this current value, just add this to V. F of L we increment by 1. And that should be it. I mean, of course, we have to actually do num1 did, so I have to put it in there. Hang on, right? And then just count it to 0. Right? And that's it. Pretty straightforward, even though I made a big deal out of this one. Let's give a quick submit. Hopefully there are no like silly numbers. Yeah, that's it. What's the complexity here? Clearly it is going to be the sorting and log n, and that's it. Yeah, first time I saw this one. But yeah, that's it. I think I was I went into details on this one a bit. So let me know what you think. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later. Take care. Bye bye.